CIET NCERT presents audiobook Ganit Prakash, textbook of mathematics for grade 7.
Chapter number 4, Expressions using letter numbers. Page number 81. On the right side of the page, you are provided with a QR code, scanning which you can reach out to the additional resources to this chapter. 4.1. The notion of letter numbers. In this chapter, we shall look at a concise way of expressing mathematical relations and patterns. We shall see how this helps us in thinking about these relationships and patterns, and in explaining why they may hold true. Example 1. Shabnam is 3 years older than Aftab. When Aftab's age 10 years, Shabnam's age will be 13 years. Now, Aftab's age is 18 years. What will Shabnam's age be? Dash. Given Aftab's age, how will you find out Shabnam's age? Easy. We add 3 to Aftab's age to get Shabnam's age. Can we write this as an expression? Shabnam's age is 3 years more than Aftab's. In short, this can be written as Shabnam's age is equal to Aftab's age plus 3. Such mathematical relations are generally represented in a shorthand form. In the relation above, instead of writing the phrase Aftab's age, the convention is to use a convenient symbol. Usually, letters or short phrases are used for this purpose. Let us say we use the letter A to denote Aftab's age. We could have used any other letter, and S to denote Shabnam's age. Then the expression to find Shabnam's age will be A plus 3, which can be written as S is equal to A plus 3. If A is 23, that is Aftab's age in years, then what is Shabnam's age? Figure 4.1. On this page, we are given Aftab's age and expression for Shabnam's age. If Aftab's age is 4, then expression for Shabnam's age will be 4 plus 3. If Aftab's age is 10, expression for Shabnam's age will be 10 plus 3. If Aftab's age is 23, then expression for Shabnam's age will be 23 plus 3. Then we have unknowns to be written. If we have A as Aftab's age, then expression for Shabnam's age will be A plus 3. Likewise, question mark and question mark plus 3. Page number 82. Replacing A by 23 in the expression A plus 3, we get S is equal to 23 plus 3 is equal to 26 years. Letters such as A and S that are used to represent numbers are called letter numbers. Mathematical expressions containing letter numbers such as the expression A plus 3 are called algebraic expressions. Given the age of Shabnam, write an expression to find Aftab's age. We know that Aftab is 3 years younger than Shabnam. So, Aftab's age will be 3 less than Shabnam's. This can be described as Aftab's age is equal to Shabnam's age minus 3. If we again use the letter A to denote Aftab's age and the letter S to denote Shabnam's age, then the algebraic expression would be A is equal to S minus 3, meaning 3 less than S. Use this expression to find Aftab's age if Shabnam's age is 20. Example 2. Parthiv is making matchstick patterns. He repeatedly places L's next to each letter. Each L has two matchsticks as given in the figure 4.2. We have figure which represents L, and then in the next one we have two L's placed next to each other, and in the next we have three L's arranged next to each other. How many matchsticks are needed to make 5 L's? It will be 5 into 2. How many matchsticks are needed to make 7 L's? It will be 7 into 2. How many matchsticks are needed to make 45 L's? It will be 45 into 2. Now, what is the relation between the number of L's and the number of sticks? First, let us describe the relationship or the pattern here. Every L needs two matchsticks. So, the number of matchsticks needed will be 2 times the number of L's. This can be written as number of matchsticks is equal to 2 into number of L's. Now, we can use any letter to denote the number of L's. Let's use N. The algebraic expression for the number of matchsticks will be 2 into N. This expression tells us how many matchsticks are needed to make N L's. To find the number of matchsticks, we just replace N by the number of L. Example 3. Ketki prepares and supplies coconut jaggery laddus. The price of a coconut is 35 rupees and the price of 1 kg jaggery is 60 rupees. Page number 83. How much should she pay if she buys 10 coconuts and 5 kg jaggery? Cost of 10 coconuts is equal to 10 into 35 rupees. Cost of 5 kg jaggery is equal to 5 into 60 rupees. Total cost is equal to 10 into 35 rupees plus 5 into 60 rupees. That is equal to 350 rupees plus 300 rupees, that is equal to 650 rupees. How much should she pay if she buys 8 coconuts and 9 kg jaggery? Write an algebraic expression to find the total amount to be paid for a given number of coconuts and quantity of jaggery. Let us identify the relationship and then write the expressions. We have a tabular column shown here with 3 columns. First one with a heading quantity needed, second column showing relationship, and the third one displaying expression. Cost of coconuts. In the relationship, we have number of coconuts into 35. And in the expression, we have C into 35. Quantity needed, cost of jaggery in the quantity needed column, and number of kgs of jaggery into 60 in relationship, and J into 60 in the expression column. Here, C represents the number of coconuts and J represents the number of kgs of jaggery. The total amount to be paid will be cost of coconuts plus cost of jaggery. The corresponding algebraic expression can be written as C into 35 plus J into 60. Use this expression or formula to find the total amount to be paid for 7 coconuts and 4 kg jaggery. Notice that for different values of C and F, the value of the expression also changes. Writing this expression as a sum of terms, we get C into 35 plus J into 60. Example 4. We are familiar with calculating the perimeters of simple shapes. Write expressions for perimeters. The perimeter of a square is 4 times the length of its side. This can be written as the expression 4 into q, where q stands for the side length. What is the perimeter of a square with side length 7 centimeters? Use the expression to find. You must have realized how the use of letter numbers and algebraic expressions allows us to express general mathematical relations in a concise way. Page number 84. Mathematical relations expressed this way are often called formulas. Figure it out. Question number 1. Write formulas for the perimeter of A. Triangle with all sides equal. B. A regular pentagon. As we have learnt last year, we use the word regular to say that all side lengths and angles measured are equal. C. A regular hexagon. Question number 2. Muniratna has a 20-meter long pipe. However, he wants a longer watering pipe for his garden. He joins another pipe of some length to this one. Give the expression for the combined length of the pipe. Use the letter number K to denote the length in meters of the other pipe. Question number 3. What is the total amount Kritika has if she has the following numbers of notes of 100 rupees, 20 rupees and 5 rupees? Complete the following table. Here we are provided a table with 4 columns. First column representing number of 100 notes. Second column number of 20 rupees notes. Third one number of 5 rupee notes. And fourth one expression and total amount. In the first row we have number of 100 notes as 3. In the second column we have number of 20 rupees notes as 5. And in the third one we have number of rupees 5 notes as 6. You are supposed to write down the expression and the total amount in the fourth column. Likewise, in the second row we have 3 blanks for number of 100 rupees notes, 20 rupees notes and 5 rupee notes. But expression and total amount is filled up. 6 into 100 plus 4 into 20 plus 3 into 5 is equal to 695. In the third row, we have number of 100 rupee notes as 8, number of 20 rupees notes as 4, number of 5 rupee notes as Z. We are supposed to write down the expression and total amount in the fourth column. Number of 100 rupee notes is X, number of 20 rupees notes is Y, number of 5 rupee notes is Z, and we are supposed to write down the expression and the total amount in the fourth column. Question number 4. Venkat Lakshmi owns a flour mill. It takes 10 seconds for the roller mill to start running. Once it is running, each kg of grain takes 8 seconds to grind into powder. Which of the following expressions here describes the total time to complete grind y kg of grain, assuming the machine is off initially? A. 10 plus 8 plus y. B. 10 plus 8 within brackets into y. C. 10 into 8 into y. D. 10 plus 8 into y. E. 10 into y plus 8. Question number 5. Write algebraic expressions using letters of your choice. A. 5 more than a number. B. 4 less than a number. Page number 85. C. 2 less than 13 times a number. D. 13 less than 2 times a number. Question number 6. Describe situations corresponding to the following algebraic expressions. A. 8 into x plus 3 into y. B. 15 into j minus 2 into k. Question number 7. In a calendar month, if any 2 by 3 grid full of dates is chosen as given in the picture, while expressions for the dates in the blank cells if the bottom middle cell has date W. We are given the month of November 2024 with the days and dates mentioned here. 6 dates have been highlighted: 12, 13, 14, 19, 20, 21. And on the right side, we have 6 boxes in which 2 boxes have been filled up as W-1 and W respectively. 4.2 Revisiting arithmetic expressions. We learned to write expressions as sums of terms, and it became easy for us to read arithmetic expressions. Many times they could have been read in multiple ways, and it was confusing. We used swapping, that is adding two numbers in any order, and grouping, that is adding numbers by grouping them conveniently, to find easy ways of evaluating expressions. Swapping and grouping terms does not change the value of the expression. We also learned to use brackets in expressions, including brackets with a negative sign outside. We learned the distributive property, that is, multiple of a sum is the same as sum of multiples. Let us revise these concepts and find the values of the following expressions. First one, 23 minus 10 into 2. Second, 83 plus 28 minus 13 plus 32. Third, 34 minus 14 plus 20. Fourth, 42 plus 15 minus within brackets 8 minus 7. Fifth one, 68 minus within brackets 18 plus 13. Sixth one, 7 into 4 plus 9 into 6. Question number 7, 20 plus 8 into within brackets 16 minus 6. Let us evaluate the first expression, 23 minus 10 into 2. First, we shall write the terms of the expression. Notice that one of the terms is a number, while the other one has to be converted to a number before adding the two terms. 23 minus 10 into 2 is equal to 23 plus minus 10 into 2, that is equal to 23 plus minus 20 is equal to 3. Page number 86. Let us now evaluate the second one. All the terms of this expression are numbers. If we notice the terms, we find that it will be easier to evaluate if we swap and group the terms. 83 plus 28 minus 13 plus 32 is equal to 83 plus 28 plus minus 13 plus 32. If we swap 83 and minus 13, we get 70. And if we swap 28 and 32, we get 60. On adding 70 and 60, we get 130. Let us now look at the fifth expression. It has brackets with a negative sign outside. This can be evaluated in two ways: by solving the bracket first, like the solution on the left side, or by removing the brackets appropriately as on the right side. that is equal to 68 plus minus within brackets 18 plus 13, that is equal to 68 plus minus 31, that is equal to 37, or 68 plus minus of 18 plus 13 within brackets can be written as 68 plus minus 18 plus minus 13. So, on subtracting 18 from 68 we get 50 plus minus 13, that is equal to 37. Now, find the values of the other arithmetic expressions. Algebraic expressions also take number values when the letter numbers they contain are replaced by numbers. In example 1, for finding Shabnam's age, when Aftab is 23 years old, we replace the letter number A in the expression A plus 3 by 23, and it took the value 26. 4.3 Omission of the multiplication symbol in algebraic expressions. Look at this number sequence: 4, 8, 12, 16, 20, 24, 28, and so on. How can we describe this sequence or pattern? Easy. These are the numbers appearing in the multiplication table of 4, multiples of 4 in an increasing order. What is the third term of the sequence? It is 4 into 3. What is the 29th term of the sequence? It is 4 into 29. Find an algebraic expression to get the nth term of this sequence. Note that here n is the letter number that denotes a position in the sequence. Page number 87. As it is the sequence of multiples of 4, it can be seen that the nth term will be 4 times n, 4 into n. As a standard practice, we shorten 4 into n to 4n by skipping the multiplication sign. We write the number first, followed by the letter or letters. Find the value of the expression 7k when k is equal to 4. The value is 7 into 4 is equal to 28. Find the value that the expression 5m plus 3 takes when m is equal to 2. As 5m stands for 5 into m, the value of the expression when m is equal to 2 is 5 into 2 plus 3, that is equal to 13. Mind the mistake, mend the mistake. Some simplifications are given here, where the letter numbers are replaced by numbers and the value of the expression is obtained. First point, observe each of them and identify if there is a mistake. Second point, if you think there is a mistake, try to explain what might have gone wrong. Point 3, then correct it and give the value of the expression. First one, if a is equal to minus 4, then 10 minus a is equal to 6. Second one, if d is equal to 6, then 3d is equal to 36. Third one, if s is equal to 7, then 3s minus 2 is equal to 15. Fourth one, if r is equal to 8, then 2r plus 1 is equal to 29. Fifth one, if j is equal to 5, then 2j is equal to 10. Sixth one, if m is equal to minus 6, then 3 into within brackets m plus 1 is equal to 19. Seventh one, if f is equal to 3, g is equal to 1, then 2f minus 2g is equal to 2. Eighth one, if t is equal to 4, b is equal to 3, then 2t plus b is equal to 24. Ninth one, if h is equal to 5, n is equal to 6, then h minus within brackets 3 minus n is equal to 4. 4.4 Simplification of algebraic expressions. Earlier, we found expressions to find perimeters of different regular figures in terms of their sides. Let us now find an expression to find the perimeter of a rectangle. Here, we are given a picture of a rectangle. Page number 88. As in the previous cases, we will first describe how to get the perimeter when the length and the breadth of the rectangle are known. Find the sum of length plus breadth plus length plus breadth. Let us use the letter numbers L and B in place of length and breadth respectively. If P denote the perimeter of the rectangle, then we have P is equal to L plus B plus L plus B. As we know, these represent numbers and so the terms of an expression can be added in any order. Hence, the above expression can be written as L plus B plus B, as L plus L is equal to 2 into L, that is equal to 2L, and B plus B is equal to 2 into B is equal to 2B. We have P is equal to 2 into L plus 2 into B. Notice that the initial expression L plus B plus L plus B within brackets and the final expression 2L plus 2B within brackets that we got for the perimeter look different. However, they are equal since the expression was obtained from the initial one by applying the same rules and operations we do for numbers. They are equal in the sense that they both take the same values when letter numbers are replaced by numbers. For example, if we assign L is equal to 3, B is equal to 4, we get L plus B plus L plus B is equal to 3 plus 4 plus 3 plus 4 is equal to 14, and 2L plus 2B is equal to 2 into 3 plus 2 into 4, that is equal to 14. We call the expression 2L plus 2B the simplified form of L plus B plus L plus B. Let us see some more examples of simplification. Example 5. Here is a table showing the number of pencils and erasers sold in a shop. The price per pencil is C and the price for eraser is D. Find the total money earned by the shopkeeper during these 3 days. Here we have a table representing day 1, day 2 and day 3 in 3 different columns, and pencil price C in first row, erasers price D in the second row. So day 1 pencils we have 5, day 2 we have pencils as 3, and in day 3 we have pencils as 10. On day 1 erasers are 4, day 2 erasers are 6, and day 3 number of erasers are 1. Let us first find the money earned by the sale of pencils. The money earned by selling pencils on day 1 is 5C. Similarly, the money earned by selling pencils on day 2 is dash and day 3 is dash. The total money earned by the sale of pencils is 5C plus 3C plus 10C. Can we simplify this expression further and reduce the number of terms? Page number 89. The expression means 5 times C is added to 3 times C is added to 10 times C. So in total, the letter number C is added 5 plus 3 plus 10 times. This is what we have seen as the distributive property of numbers. Thus, 5 into C plus 3 into C plus 10 into C is equal to 5 plus 3 plus 10 into C. 5 plus 3 plus 10 into C can be simplified to 18 into C, that is equal to 18C. If C is equal to 50 rupees, find the total amount earned by the scale of pencils. Write the expression for the total money earned by selling erasers. Then simplify the expression. The expression for the total money earned by selling pencils and erasers during these 3 days is 18C plus 11D. Can the expression 18C plus 11D be simplified further? There is no way of further simplifying this expression as it contains different letter numbers. It is in its simplest form. In this problem, we saw the expression 5C plus 3C plus 10C getting simplified to the expression 18C. Check that both expressions take the same value when C is replaced by different numbers. Example 6. A big rectangle is split into two smaller rectangles as given. Write an expression describing the area of the bigger rectangle. We are having a picture of a rectangle which is divided in two parts, and the measurements of the rectangles with lengths 4 and 3 are seen here, and breadth is V. This is another way of seeing the distributive property. The areas of the smaller rectangles are 4 into V square units and 3 into V square units. The area of the bigger rectangle can be found in two ways. First, by directly using its side length V and 4 plus 3, or second, by adding the areas of the smaller rectangles. The first way gives 7V and the second way gives 4V plus 3V. We know that they are equal. 4V plus 3V is equal to 7V, and this is the required expression for the area of the bigger rectangle. As earlier, a big rectangle is split into two smaller rectangles as given below. Write an expression to find the area of the rectangle AEFD. Page number 90. Even in this case, the area of rectangle AEFD can be found in two ways. First, by directly using the side length n and 12 minus 4, or second, subtracting the area of the rectangle EBCF from that of ABCD. Here we have a picture of a rectangle ABCD with EF as a line which is dividing the rectangle into two different rectangles, and with CF marked as 4 and AB marked as 12 and AD marked as N. The first method gives us 8 into N and the second method gives us 12N minus 4N, and they are equal since 12N minus 4N is equal to 8N. This is the expression for the area of the rectangle AEFD. Sets of terms such as 5C, C, 10C, 12N, minus 4N that involve the same letter numbers are called like terms. Sets of terms such as 18C, 11D are called unlike terms as they have different letter numbers. As we have seen, like terms can be added together and simplified into a single term. Example 7. A shop rents out chairs and tables for a day's use. To rent them, one has to first pay the following amount per piece. When the furniture is returned, the shopkeeper pays back some amount as follows. Write an expression for the total number of rupees paid if X chairs and Y tables are rented. For X chairs and Y tables, let us find the total amount paid at the beginning and the amount one gets back after returning the furniture. Here we have two tables in which item and the amount is represented. Chair, the amount is 40 rupees. For table, the amount is 75 rupees. And amount returned is, for chair it is 6 rupees and for table it is 10 rupees. Describe the procedure to get these amounts. The total amount in rupees paid at the beginning is 40x plus 70y, and the total amount returned is 6x plus 10y. So, the total amount paid is equal to 40x plus 75y within brackets minus 6x plus 10y within brackets. Can we simplify this expression? If yes, how? If not, why not? Page number 91. Recalling how we open brackets in an arithmetic expression, we get 40x plus 75y within brackets minus 6x plus 10y within brackets is equal to 40x plus 75y within brackets minus 6x minus 10y. Since the terms can be added in any order, the remaining bracket can be opened and the expression becomes 40x plus 75y plus minus 6x plus minus 10y. We can group the like terms together. This results in 40x plus minus 6x plus 75y plus minus 10y. That is equal to 40 minus 6 into x plus 75 minus 10 within brackets into y. That is equal to 34x plus 65y. The expression 40x plus 75y within brackets minus 6x plus 10y within brackets is simplified to 34x plus 65y, which is the total amount paid in rupees. Could we have written the initial expression as 40x plus 75y within brackets plus minus 6x minus 10y within brackets? Example 8. Charu has been through 3 rounds of a quiz. Her scores in the 3 rounds are 7p minus 3q, 8p minus 4q and 6p minus 2q. Here, p represents the score for a correct answer and q represents the penalty for an incorrect answer. What do each of the expression mean? If the score for a correct answer is 4, that is p is equal to 4, and the penalty for a wrong answer is 1, that is q is equal to 1, find Charu's score in the first round. Charu's score is 7 into 4 minus 3 into 1. We can evaluate this expression by writing it as a sum of terms. 7 into 4 minus 3 into 1 is equal to 7 into 4 plus minus 3 into 1, that is equal to 28 plus minus 3, that is equal to 25. What are her scores in the second and third rounds? What if there is no penalty? What will be the value of q in that situation? What is her final score after the 3 rounds? Her final score will be the sum of the 3 scores. 7p minus 3q within brackets plus 8p minus 4q within brackets plus 6p minus 2q within brackets. Since the terms can be added in any order, we can remove the brackets and write 7p plus minus 3q plus 8p plus minus 4q plus 6p plus minus 2q is equal to 7p plus 8p plus 6p plus minus 3q plus minus 4q plus minus 2q by swapping and grouping. That is equal to 7 plus 8 plus 6 within brackets into p plus minus within brackets 3 plus 4 plus 2 into q. That is equal to 21p plus minus 9q. That is equal to 21p minus 9q. Charu's total score after 3 rounds is 21p minus 9q. Her friend Krishita's score after 3 rounds is 23p minus 7q. Page number 92. Give some possible scores for Krishita in the 3 rounds so that they add up to give 23p minus 7q. Can we say who scored more? Can you explain why? How much more has Krishita scored than Charu? This can be found by finding the difference between the two scores. 23p minus 7q minus within brackets 21p minus 9q. Simplify this expression further. Example 9. Simplify the expression 4 into x plus y within brackets minus y. Using the distributive property, this expression can be simplified to 4 into within brackets x plus y minus y is equal to 4x plus 4y minus y. That is equal to 4x plus 4y plus minus y. That is equal to 4x plus within brackets 4 minus 1 into y. That is equal to 4x plus 3y. Example 10. Are the expressions 5u and 5 plus u equal to each other? The expression 5u means 5 times the number u, and the expression 5 plus u means 5 more than the number u. These two being different operations, they should give different values for most values of u. Let us check this. Fill the blanks given by replacing the letter numbers by numbers. An example is given here. Then compare the values that 5u and 5 plus u take. Here we have 5 boxes. The middle box has 5u in it, and when u is equal to 2, the value becomes 10. And when u is equal to 11, we require to fill the value in the box. When u is equal to 8, we have to write down the value in the box. When u is equal to 5, we need to write down the value in the box. Similarly, in the next figure, we have 5 plus u. When u is equal to 2, the value is 7. And when u is equal to 11, the value is to be written in the blank box. And when u is equal to 8, the value is to be written in the box. And when u is equal to 5, we need to write down the value in the blank box. If the expressions 5u and 5 plus u are equal, then they should take the same values for any given value of u. Page number 93. But we can see that they do not. So, these two expressions are not equal. Are the expressions 10y minus 3 and 10 into within brackets y minus 3 equal? 10y minus 3, short for 10 into y minus 3, means 3 less than 10 times y. 10 times y minus 3, short for 10 into y minus 3, means 10 times 3 less than y. Let us compare the values that these expressions take for different values of y. We have here 5 boxes. The middle box displays the value 10y minus 3. When y is equal to 0, we have to calculate and write down the value in the box. And when y is equal to 7, we have to calculate and write down the value in the box. Same way, when y is equal to 10, we have to calculate and write down the value in the box. When y is equal to 2, the value is calculated and given as 17. Similarly, in the second picture, we have the middle box displaying the value 10 into y minus 3. When y is equal to 0, we need to calculate and write down the value in the blank box. When y is equal to 7, we have to write down the value in the blank box. When y is equal to 10, we have to calculate and write down in the blank box. And when y is equal to 2, the value is calculated and given as minus 10 in the box. After filling in the two diagrams, do you think the two expressions are equal? Example 11. What is the sum of the numbers in the picture? Unknown values are denoted by letter numbers. There are many ways to go about it. Here we show some of them. First one, adding row wise gives 4 into 3 plus r plus s within brackets plus r plus s within brackets plus 4 into 3. Second one, adding like terms together gives 8 into 3 plus within brackets r plus within brackets s plus s. Third one, adding the upper half and doubling gives 2 into within brackets 4 into 3 plus r plus s. The three expressions might seem different. We can simplify each one and see that they all are the same. 2r plus 2s plus 24. In the right side of the page, we are given boxes in which digit 3 is written, and in the circles we have r and s written 2 times. RR and SS in yellow and purple color respectively. Figure it out. Question number 1. Add the numbers in each picture below. Write their corresponding expressions and simplify them. Try adding the numbers in each picture in a couple different ways and see that you get the same thing.
Page 94.
Here we have in the picture 3 different situations. First one, we have 2 squares with numbers minus 6 and 2 and 4 circles with letters x, 5y and 5y. In the second one, we have 4 digits in squares as minus 2, 3 and 3, and we have 4 circles with letters as 2p, 3q, 2p. Similarly, below in the same column we have 2p, 3q and 2p. In the third situation, we have 4 rows and 4 columns. In the first row, we have 5g, 5k, minus 5g. Second row, we have 5k, and 5k. Similarly, in the third row, we have 5k. In the fourth row, we have minus 5g, 5k, 5k and minus 5g. Question number 2. Simplify each of the following expressions. A. P plus P plus P plus P, comma, P plus P plus P plus Q. P plus Q plus P minus Q. B is P minus Q plus P minus Q. P plus Q minus P plus Q. C. P plus Q minus within brackets P plus Q. P minus Q minus P minus Q. D. 2D minus D minus D minus D. 2D minus D minus D minus C. E. 2D minus D minus within brackets D minus C. 2D minus within brackets D minus D minus C. F. 2D minus D minus C minus C. Mind the mistake, mend the mistake. Some simplifications of algebraic expressions are given below. The expression on the right hand side should be in its simplest form. First point, observe each of them and see if there is a mistake. Second point, if you think there is a mistake, try to explain what might have gone wrong. Third point, then simplify it correctly. We have 3 columns below this: expression, simplest form, and the third column has correct simplest form. First one, 3a plus 2b. Simplest form is 5. We need to write down the correct simplest form. Second one, 3b minus 2b minus b. Simplest form is 0. We need to write the correct simplest form for this also. Third one, 6 into p plus 2 within brackets. Simplest form is 6p plus 8. We need to correct the simplest form here. Fourth one, 4x plus 3y within brackets minus 3x plus 4y within brackets. Simplest form is x plus y. We need to write down the correct simplest form. Fifth one, 5 minus within brackets 2 minus 6z. Simplest form is 3 minus 6z. We need to write down the correct simplest form. Seventh one, 2y plus within brackets 3y minus 6. Simplest form minus y plus 6. We need to write down the correct simplest form for this also. Eighth one, 7p minus p plus 5q minus 2q. Simplest form is 7p plus 3q. We need to write down the correct simplest form. Ninth one, 5 within brackets 2w plus 3x plus 4w. Simplest form is 10w plus 15x plus 20w. We need to write down the correct simplest form. Page number 95. 10th one, 3j plus 6k plus 9h plus 12. The simplest form is 3 within brackets j plus 2k plus 3h plus 4. We need to write the correct simplest form. 11th one, 4 into within brackets 2r plus 3s plus 5. Simplest form is minus 20 minus 8r minus 12s. We need to write down the correct simplest form. Take a look at all the corrected simplest forms. That is, brackets are removed, like terms are added, and terms with only numbers are also added. Is there any relation between the number of terms and the number of letter numbers these expressions have? 4.5. Pick patterns and reveal relationships. In the first section, we got a glimpse of algebraic expressions and how to use them to describe simple patterns and relationships in a concise and elegant manner. Here, we continue to look for general relationships between quantities in different scenarios, find patterns, and interestingly, even explain why these patterns occur. Remember the importance of describing in simple language or visualizing mathematical relationships before trying to write them as expressions. Formula detective. Observe the picture given. In each case, the number machine takes in the two numbers at the top of the y as inputs, performs some operations, and produces the result at the bottom. The machine performs the same operations on its inputs in each case. Find out the formula of this number machine. We have numbers as 5 and 2, and it gives the output as 8. We need to write down the expression. In the next one, the numbers as input are 8 and 1 and output is 15. We need to write down the expression. In the third one, numbers are 9 and 11 and output is 7. We need to write down the expression. The input here are 10 and output is 10. The expression is to be written. The input numbers are 6 and 4 and we need to write down the output as well as the expression. The formula for the number machine above is 2 times the first number minus the second number. When written as an algebraic expression, the formula is 2a minus b. The expression for the first set of input is 2 into 5 minus 2, that is equal to 8. Check that the formula holds true for each set of inputs. Page number 96. Find the formulas of the number machines given here and write the expression for each set of inputs. We have 5 setups. In the first one, the input numbers are 5 and 2 and the output is 5. We need to write down the expression. In the second one, the input numbers are 8 and 1, output is 7. We need to write down the expression. The input numbers are 9 and 11 and the output is 18. We need to write down the expression. The input numbers are 10 and 10 and output number is 18. We need to write down the expression. In the fifth one, the input numbers are A and B and we need to write down the output as well as the expression. In the second row, we have 5 machines with input numbers 4 and 1 and output as 5. We need to write down the expression. In the next machine, the input numbers are 6 and 0 and output is 1. We need to write down the expression. In the next, the input numbers are 3 and 2 and output is 7. We need to write down the expression. In the next, the input numbers are 10 and 3 and we need to write down the output as well as the expression. In the last one, the input letters are A and B. We need to write down the output letter and the expression. Now, make a formula on your own. Write a few number machines as examples using that formula. Challenge your classmates to figure it out. Note to the teacher: not just solving problems, but creating new questions is also very much a part of learning and doing mathematics. Algebraic expressions to describe patterns. Example 12. Somjit noticed a repeating pattern along the border of a sari. We have some designs given here as A, B, C, D, E and F. Somjit wonders if there is a way to describe all the positions where the first design A occurs, 2. design B occurs, and 3. design C occurs. Page number 97. Let us start with design C. It appears for the first time at position 3 and second time at position 6. Where would design C appear for the nth time? We can see that this design appears in positions that are multiples of 3. So the nth occurrence of design C will be at position 3n. Similarly, find the formula that gives the position where the other designs appear for the nth time. The positions where B occurs are 2, 5, 8, 11, 14 and so on. We can see that the position of the nth appearance of design B is 1 less than the position at which design C appears for the nth time. Thus, the nth occurrence of design B is at position 3n-1. Similarly, the expression describing the position at which the design A appears for the nth time is 3n-2. Given a position number, can we find out the design that appears there? Which design appears at position 122? If the position is a multiple of 3, then clearly we have design C. As seen earlier, if the position is 1 less than a multiple of 3, it has design B. And if it is 2 less than a multiple of 3, then it has design A. Can the remainder obtained by dividing the position number by 3 be used for this? Observe the table given. We have a table with 3 columns. First one with position number, second quotient on division by 3, third remainder. In the first row, position number is 99, quotient on division by 3 is 33 and remainder is 0. In the second row, number is 122, the quotient on division by 3 is 40 and remainder is 2. Position number in third row is 148, quotient on division by 3 is 49 and remainder in the third row is 1. Use this to find what design appears at positions 99, 122 and 148. Patterns in a calendar. Here is the calendar of November 2024. Consider 2 by 2 squares as marked in the calendar. The numbers in this square show an interesting property. Page number 98. We have picture of month November 2024 with the dates highlighted as 12, 13, 14, 19, 20, 21. Let us take the marked 2 by 2 square and consider the numbers lying on the diagonals. 12 and 20, 13 and 19. Find their sums. 12 plus 20, 13 plus 19. What do you observe? They are equal. We have a square with 4 squares in it with numbers 12, 13, 19 and 20. Let us extend the numbers in the calendar beyond 30, creating endless rows. We have a picture of month November 2024 with extended numbers. Will the diagonal sums be equal in every 2 by 2 square in this endless grid? How can we be sure? To be sure of this, we cannot check with all 2 by 2 squares as there are an unlimited number of them. Let us consider a 2 by 2 square. Its top left number can be any number. Let us call it as A. Given that we know the top left number, how do we find the other numbers in this 2 by 2 square? As we have been doing, first let us describe the other numbers in words. Here we have 4 boxes with one left corner box is having the letter A and others we need to fill. Page number 99. The number to the right of A will be 1 more than it. The number below A will be 7 more than it. The number diagonal to A will be 8 more than it. So, the other numbers in the 2 by 2 square can be represented as given in the grid. Let us find the diagonal sums A plus 8 within brackets and A plus 1 within brackets plus A plus 7 within brackets. Let us simplify them. Since the terms can be added in any order, the brackets can be opened. A plus 8 is equal to A plus 8, that is equal to 2A plus 8. A plus 1 within brackets plus A plus 7 within brackets is equal to A plus 1 plus A plus 7, that is equal to A plus 1 plus 7, that is equal to 2A plus 8. We see that both diagonal sums are equal to 2A plus 8, that is 8 more than 2 times A. On the right side, we have 4 boxes with expressions A plus 1, A plus 7 and A plus 8. Verify this expression for diagonal sums by considering any 2 by 2 square and taking its top left number to be A. Thus, we have shown that diagonal sums are equal for any value of A, that is, for any 2 by 2 square. This problem is an example that shows the power of algebraic modeling in verifying whether a pattern will always hold. Consider a set of numbers from the calendar having endless rows forming under the following shape. We have here 3 by 3 square grid in which the numbers are written in the middle row and middle column. In the middle row, the numbers are 14, 15, 16, and in the middle column, we have 8, 15, 22. Find the sum of all the numbers. Compare it with the number in the center, 15. Repeat this for another set of numbers that forms this shape. What do you observe? We see that the total sum is always 5 times the number in the center. Will this always happen? How do you show this? Hint: consider a general set of numbers that forms this shape. Take the number at the center to be A. Express the other numbers in terms of A. Find other shapes for which the sum of the numbers within the figure is always a multiple of one of the numbers. Page number 100. Matchstick patterns. Look at the picture given. It is a pattern using matchsticks. Can you identify what the pattern is? In the first one, we have a triangle formed by 3 matchsticks. In the second figure, we have 5 matchsticks forming 2 triangles. In the third figure, we have 7 matchsticks forming 3 triangles. In the fourth one, we are having 9 matchsticks forming 4 triangles. We can see that step 1 has 1 triangle, step 2 has 2 triangles, step 3 has 3 triangles, and so on. Can you tell how many matchsticks there will be in the next step? Step 5. It is 11. You can also draw this and see. How many matchsticks will there be in step 33, step 84, and step 108? Of course, we can draw and count. But is there a quicker way to find the answers using the pattern present here? What is the general rule to find the number of matchsticks in the next step? We can see that at each step, 2 matchsticks are placed to get the next one. That is, the number of matchsticks increases by 2 every time. We have a tabular column here with 2 rows. First one for step number and second row is for number of sticks. In the first step number 1, we have number of matchsticks 3. In step number 2, we have matchsticks 5. In step number 3, number of matchsticks are 7. In step number 4, we have number of matchsticks as 9. In step number 5, the number of matchsticks are 11. In step number 6, the number of matchsticks are 13. Think of a way to use this to find out the number of matchsticks in step 33 without continuing to write the numbers. As each time 2 matchsticks are being added, finding out how many 2's will be added in step 33 will help. Look at the table below and try to find out. We have a tabular column in which we have 3 rows. First row is step number, second row for number of matchsticks, and in the third row, split of the matchsticks is explained. Step number 1, number of matchsticks is 3. In step number 2, number of matchsticks is 5, which can be written as 3 plus 2. Step number 3, number of matchsticks 7, which can be written as 3 plus 2 plus 2. In step number 4, number of matchsticks is 9, which can be expressed as 3 plus 2 plus 2 plus 2. In step number 5, the number of matchsticks is 11, 3 plus 2 plus 2 plus 2 plus 2. In step number 6, number of matchsticks is 13. So, the number of matchsticks needed to make 33 triangles, that is step 33, is dash. Similarly, find the number of matchsticks needed for step 84 and step 108. Page number 101. What could be an expression describing the rule or formula to find out the number of matchsticks at any step? The pattern is such that in step 10, 9 2's and an added 3, that is 3 plus 2 into 9, gives the number of matchsticks. In step 11, 10 2's and an added 3, that is 3 plus 2 into 10, gives the number of matchsticks. For step y, what is the expression? It is 1 less than y, that is y minus 1, 2s and a3. Therefore, the expression is 3 plus 2 into y minus 1. This expression gives the number of matchsticks in step y. Now, we can find the number of matchsticks at any step quickly. You might have already noticed that there is a 2 in the first step also. 3 is equal to 1 plus 2. Using this, the expression we get is 2y plus 1. Does the above expression also gives the number of matchsticks at each step correctly? Are these expressions the same? We can check by simplifying the expression 3 plus 2 into within brackets y minus 1. 3 plus 2 into within brackets y minus 1 is equal to 3 plus 2y minus 2, that is equal to 2y plus 1. Both expressions are the same. There is a different way to count or see the pattern. Let us take a look at the picture again. Here we have pictures of one triangle, two triangles and three triangles. Matchsticks are placed in two orientations. A. Horizontal ones at the top and bottom, and B. the ones placed diagonally in the middle. For example, in step 2, there are 2 matchsticks placed horizontally and 3 matchsticks placed diagonally. What are these numbers in step 3 and step 4? How does the number of matchsticks change in each orientation as the step increase? Write an expression for the number of matchsticks at step y in each orientation. Do the two expressions add up to 2y plus 1? Page number 102. Figure it out. For the problems asking you to find suitable expressions, first try to understand the relationship between the different quantities in the situation described. If required, assume some values for the unknowns and try to find the relationship. Question number 1. One plate of jawar roti cost 30 rupees and one plate of pulao cost 20 rupees. If X plates of jawar roti and Y plates of pulao were ordered in a day, which expressions describe the total amount in rupees earned that day? A. 30x plus 20y, B. 30 plus 20 within brackets into x plus y within brackets, C. 20x plus 30y, D. 30 plus 20 within brackets into x plus y, E. 30x minus 20y. Question number 2. Pushpita sells two types of flowers on Independence Day: champak and marigold. P customers only bought champak. Q customers only bought marigold, and R customers bought both. On the same day, she gave away a tiny national flag to every customer. How many flags did she give away that day? A. P plus Q plus R, B. P plus Q plus 2R, C. 2 into within brackets P plus Q plus R, D. P plus Q plus R plus 2, E. P plus Q plus R plus 1, F. 2 into within brackets P plus Q. Question number 3. A snail is trying to climb along the wall of a deep well. Using the day, it climbs up u centimeters, and during the night, it slowly slips down d centimeters. This happens for 10 days and 10 nights. A. Write an expression describing how far away the snail is from its starting position. B. What can we say about the snail's movement if d is greater than u? Question number 4. Radha is preparing for a cycling race and practices daily. The first week she cycles 5 kilometers every day. Every week she increases the daily distance cycled by z kilometers. How many kilometers would Radha have cycled after 3 weeks? Question number 5. In the following figure, observe how the expression w plus 2 becomes 4w plus 20 along one path. Fill in the missing blanks on the remaining paths. The ovals contain expressions and the boxes contain operations. Here, we are given a pattern with ovals and squares. Some numbers have been written in the squares and expressions have been written in the ovals. We are provided ovals with expressions. We need to complete the ovals as some of them are blank. Page number 103. Question number 6. A local train from Yahanpur to Wahanpur stops at 3 stations at equal distances along the way. The time taken in minutes to travel from one station to the next station is the same as is denoted by T. The train stops for 2 minutes at each of the 3 stations. A. If T is equal to 4, what is the time taken to travel from Yahanpur to Wahanpur? B. What is the algebraic expression for the time taken to travel from Yahanpur to Wahanpur? Hint is, draw a rough diagram to visualize the situation. Question number 7. Simplify the following expressions. A. 3a plus 9b minus 6 plus 8a minus 4b minus 7a plus 16. B. 3 into within brackets 3a minus 3b minus 8a minus 4b minus 16. C. 2 into within brackets 2x minus 3 plus 8x plus 12. D. 8x minus within brackets 2x minus 3 plus 12. E. 8h minus within brackets 5 plus 7h plus 9. F. 23 plus 4 into within brackets 6m minus 3n minus 8n minus 3m minus 18. Question number 8. Add the expressions given below. A. 4d minus 7c plus 9 and 8c minus 11 plus 9d. B. Minus 6f plus 19 minus 8s and minus 23 plus 13f plus 12s. C. 8d minus 14c plus 9 and 16c minus within brackets 11 plus 9d. D. 6f minus 20 plus 8s and 23 minus 13f minus 12s. E. 13m minus 12n and 12n minus 13m. F. Minus 26m plus 24n and 26m minus 24n. Question number 9. Subtract the expressions given here. A. 9a minus 6b plus 14 from 6a plus 9b minus 18. B. Minus 15x plus 13 minus 9y from 7y minus 10 plus 3x. C. 17g plus 9 minus 7h from 11 minus 10g plus 3h. D. 9a minus 6b plus 14 from 6a minus within brackets 9b plus 18. E. 10x plus 2 plus 10y from minus 3y plus 8 minus 3x. F. 8g plus 4h minus 10 from 7h minus 8g plus 20. Question number 10. Describe situations corresponding to the following algebraic expressions. A. 8x plus 3y. B. 15x minus 2x. 11. Imagine a straight rope. If it is cut once, as given in the picture, we get 2 pieces. If the rope is folded once and then cut as given, we get 3 pieces. Page number 104. Observe the pattern and find the number of pieces if the rope is folded 10 times and cut. What is the expression for the number of pieces when the rope is folded r times and cut? Here we are given the rope and it is divided into two parts in the first picture. In the second one, it is folded and cut. It is dividing into three pieces. And in the next picture, we have the rope cut into four pieces. Question number 12. Look at the matchstick pattern below. Observe and identify the pattern. How many matchsticks are required to make 10 such squares? How many are required to make W squares? Here we have a picture of squares in three different situations. In the first one, the 4 matchsticks are used to make a square. And in the second one, we have 7 matchsticks to form 2 squares. And in the third one, we have 10 match squares to form 3 squares. Question number 13. Have you noticed how the colors change in a traffic signal? The sequence of color change is given below. Find the color at positions 90, 190 and 343. Write expressions to describe the positions for each color. We are given red, yellow, green as 1, 2 and 3, and at the fourth position we have yellow and fifth position we have red. We need to write down the expression to describe the position of each color. Question number 14. Observe the pattern below. How many squares will be there in step 4, step 10, step 50? Write a general formula. How would the formula change if we want to count the number of vertices of all the squares? In the first situation, we have 5 squares placed, 1 in the center and 4 squares at the corner. In the second situation, we have 5 squares in one diagonal and 5 squares in the other diagonal. In the next situation, we have 7 squares in one diagonal and likewise 7 squares in the other diagonal. Page number 105. Question number 15. Numbers are written in a particular sequence in this endless 4-column grid. A. Give expressions to generate all the numbers in a given column. 1, 2, 3, 4. B. In which row and column will the following numbers appear? 1. 124. Second, 147. Third one, 201. C. What number appears in the row R and column C? D. Observe the positions of multiples of 3. Do you see any pattern in it? List other patterns that you see. In the picture, we have 4 by 4 grid in which we have numbers as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. And there are numbers written 1, 2, 3, 4 in the respective columns above the columns. Summary. Algebraic expressions are used in formulas to model patterns and mathematical relationships between quantities and to make predictions. Next point, algebraic expressions use not only numbers but also letter numbers. The rules for manipulating arithmetic expressions also apply to algebraic expressions. These rules can be used to reduce algebraic expressions to their simplest forms. Next point, algebraic expressions can be described in ordinary language and vice versa. Patterns or relationships that are easily written using algebra can often be long and complex in ordinary language. This is one of the advantages of algebra. This is the end of chapter 4.
Ganit Prakash, you were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration, Swarnlata Sharma. Sound recordist, Prasoon Kumar. Production assistant, Soumya Malik. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.